Sear, John Glevy, and Rob Bertini. Welcome to our seminar. Before I introduce our speaker, I'm going to remind everyone, if you didn't know, we do webcast the seminars, so people are watching both live and after the fact on the web. And because of that, when you do ask questions, please use the microphone. There's usually one on every table. You need to press the touch button area, keep the red light lit while you are asking the question so that the people watching on the web, and we do have people who do watch on the web, so they can hear your question. So, and if you are forgetting, I'm going to be watching from the back and nagging you, so please remember. So anyway, without further ado, I'll introduce our speaker, who's Gregg Lande. He is a senior air quality planner with the Oregon's Department of Environmental Quality, the Air Quality Division. He has over 30 years of experience working at DEQ in air monitoring, sample analysis, quality assurance, and air quality planning, with some brief stints in hazardous waste, asbestos, Title V permitting, and small business assistance. He's currently working on air toxics policy and program development. He has a BA in chemistry and an MA in environmental health. He's going to be talking today about air toxics and particularly mobile sources.
So the red light's on and it's working now, right? Okay, so I'll start again. So as Jennifer mentioned, I've got a broad experience. My knowledge base is pretty broad, but I maybe don't know a whole lot about all these topics I'm going to cover. I'm going to cover a lot of ground. And so as a result, I've put a lot of website information in here, and I've got some contact information at the end. And if you have questions about any of this stuff, you'd like to delve a little deeper, this should help you get started. I guess two basic websites would be the DEQ website, and you can go there and get to air quality and get into all these topics, or the EPA website, and you can go there in their air quality program as well and get to a lot of this stuff. And I guess I'd appreciate it if you'd hold your questions till the end. And I can stick around until whenever to answer questions. And I kind of hope I generate a few questions here. This audience doesn't know a whole lot about air quality, I have a hunch. And so I'm kind of going to start at the beginning and cover a lot of things, like I said. And we can talk about it more later. I'm kind of hoping that you come away from this with a pretty good feel about what air pollution is about the importance in terms of health impacts, and something about what the sources of air pollution are. I'm going to talk also about, specifically, I'm going to focus in on toxic air pollutants in Oregon and what the DEQ has done in response to identifying toxic air pollutant problems. And of course, all through this, I'll be kind of going back to what's the role of transportation in all this. And then I guess I'm going to finish up with a little bit about our legislative agenda. You guys may not be all that tuned into it, but right now, the legislature being in session is a big deal for us because a lot's going to happen there, and we're really hopeful that they'll do some good things for our budget. One thing I want to get straight right off the bat, I work for the state of Oregon, Department of Environmental Quality. That is not the same as the United States Environmental Protection Agency. We work a lot together, and we work well together. But they're two different agencies. They have different authorities. They do things different. A lot of folks don't recognize the difference. So it's kind of important. And again, you'll see throughout this thing that there's some references to EPA websites, some references to DEQ ones. Let's see if this works. That didn't work. Okay, that didn't work. Oh, there we go. Okay, so you've probably seen these headlines. More recently, the benzene one. And the other one came out a couple years ago after an EPA study came out and compared air quality across the country. We have air quality problems here. I think we all realize that. But, do you really think it's as bad as that? Third worst in the country? I mean, I grew up in Chicago, and you could see it, and you could taste it, and you could smell it. I mean, it's just not like that around here. I guess, the other question is, where does this stuff fit in terms of transportation? One of the interesting elements of the benzene story is you'll find that if you dig enough into it, one of the reasons this has come up is because our air quality is actually pretty good in Portland. And so there haven't been regulations on benzene sources in the past. And so, there's a contradiction going on there between benzene. The benzene story says our air is good. The headlines from an EPA study says it's bad. So we're going to have to try and get into why that is. Let's talk a little bit about the problem first. EPA has done a modeling study looking at air pollution across the country, looking at concentrations. And what you see here is what the state of Oregon looks like. The colors are actually comparative colors, relative risk for cancer compared to the rest of the country. The important part that you want to get from this is, not surprisingly, the metropolitan area looks worse than any place else. And I think, based on what we know about population and all the different kinds of sources, that's not to be unexpected. Again, this is from the EPA study back in '99. Here we have a map. It shows non-cancer risk. This is from air pollutants that don't cause cancer but cause other serious health effects. And again, the valley still looks bad, but kind of the interesting thing, anything that isn't green, essentially, is an area of concern that we have in Oregon. And, it might be surprising to look out there in southeastern Oregon and say, what the heck's going on there? It's not just about cars, there's other things. So, as a result of studies like that and other work that we've done, we've identified this group of pollutants as what we really want to focus on. And this is where our focus is in this legislative session. We're going to be talking with the legislature. The governor's presented a budget to help us resolve problems we have with these 4 pollutants. And I guess that's an important thing to say, is how we operate a little bit. We have a tendency to do the science and stuff to figure out where we have a problem and then try and figure out what are possible solutions and then work with communities or sources, whatever they might be, to solve problems. It's a very kind of concrete thing. You probably know that DEQ is involved in regional transportation planning or transportation planning around the state. Mostly it's to remind people that air quality is important, that it has public health impacts. And it's not necessarily, it's just one of the factors I imagine that you regional urban transportation planners think about. At least I hope you do. I guess one good example from a while ago of how DEQ really kind of got injected into transportation planning is we used to have a parking lid in downtown Portland, which basically mandated how many parking spaces there were in the downtown core area. Now, that had something to do, that affected transportation in some way. So the governor's legislative agenda for DEQ is a health-based agenda. It focuses on these things. Combustion byproducts, essentially, lots of chemicals come out of burning things. A whole array of different stuff. I won't try to name them all. Vehicle exhaust is one source of combustion products. Wood burning in stoves, in home stoves, is another source. Benzene, basically, very much associated with transportation. It's in our fuels, and it's in the exhaust from pretty much any kind of combustion engines. And then diesel particulate, kind of a special little subset. Diesel particulate matter actually is just a part of what's in diesel exhaust. Hundreds of chemicals, many of them toxic. And diesel particulate, comes again from pretty much, comes from every diesel engine there is. I'll talk a little bit more about sources in a minute. I'm not going to really focus very much, or I'm hardly going to say anything about the federal fine particulate standard, or fine particulate. What happened was back in September of 2006, EPA put forward a new national ambient air quality standard for fine particulate. And what fine particulate is particles that have an aerodynamic diameter of less than 2.5 microns. Pretty small particles. When I started out in this business 30 years ago, we were talking about total suspended particulate, things as big as 100 microns. And actually we even dealt with stuff like wood chips falling in people's yards from the sawmill next door and things like that. But over the years, they've ratcheted down not only the concentration of what's allowed in the air, but also the size, as they've recognized that the finer particles are the ones that get inhaled deeply into the lungs and really cause the most health effects. So back in 2006, when EPA came out with the new standard, they dropped it from a concentration of 65 micrograms per cubic meter to 35 micrograms per cubic meter as a daily standard. What that did was put 2 Oregon cities, Oak Ridge and Klamath Falls, in jeopardy of violating those standards. We have data already that suggests that they're going to be in violation of those standards. In addition, we've got about another 5 cities. What do we got there? Medford, Lakeview. Let's see if I can't read it sideways. Hermiston, Pendleton, and I thought there was one more. Well, anyhow, those are really close. Based on the data that we have at this point, it's a good chance they're going to violate the standard. We still need to gather data for another couple years before we know for sure. And then all the green ones, which does include the Portland area, are really at risk of violating that standard. An interesting aspect is, the air quality hasn't changed. It's the standard that's changed. And now we've gone from a place where Oregon was essentially met all the federal fine particulate standards previously. All of a sudden, we've got a bunch of places that might violate the standard. And that has some pretty important implications for transportation planning, among other things. But like I said, I'm not going to talk too much about that. To give you an idea, when EPA proposed or promulgated this rule, they estimated there were about 40 counties in the country that were going to be in violation of the new standards. And we've got a few of them. Okay, so why do we worry about these pollutants? Smoke, fine particulate, as I said. Asthma, it's mostly about respiratory disease, although there's more and more data out there now that it affects cardiovascular systems, so it's impacting heart health, and it's pretty big. It's pretty important. Benzene, mostly implicated in cancers, cancer of the blood, leukemia, other blood disorders. And diesel exhaust, diesel particulate, again, cancer, lung cancer, again, heart, lung diseases. I'll just toss that in, global warming as well. Turns out that carbon sits pretty important. It's more potent than CO2 as a global warming contributor. And then I don't have combustion products on this slide, but essentially combustion products do all those. So, the smoke from wood stoves and the smoke from diesel engines and cars, it's doing all that stuff. So how do we get there? How do we go about solving these problems? How do we figure out what's going on, define the problem, get the solutions? These are some of the scientific tools we use. Toxicology and epidemiology, ways to look at toxicology being, well, maybe you don't know, I don't know. You basically expose some organism to some chemical and you see what the effect is and at what concentration bad things start to happen. Epidemiology, you follow populations of people. You see how their health is affected by certain environmental impacts, as one example of epidemiology. Air monitoring, I'll talk a little bit more about air monitoring, but we have a fairly extensive air monitoring network in the state, pretty much like every other state. Emissions inventory is a real important part of what we do. It helps us to identify what the sources are and quantify how much they're contributing. And that's really important when you get around to trying to figure out how you're going to reduce things. What source types are you going to talk about when you want to talk about reductions? And then we use modeling. There's a lot of different kinds of models that we use. Primarily, we're talking about models that say when you release a pollutant here, what's the concentration over here? But there's lots of other models as well. There are models, and I'll talk about that in just a bit. So, first off, if I were to ask you, what do you think sources of air pollution are? Probably the first thing you'd come up with is the smokestacks. I mean, pretty much, oh, no, good. Okay, you guys are transportation planners. You know better than that. Okay, so smokestacks. But I've got the second picture there because you don't often think about the fact that there's all this process stuff going on inside factories with pipes and valves and flanges and whatnot that leak chemicals. And oftentimes they leak into the building, and then of course you've got to ventilate the building because you've got to protect the workers. And sometimes you don't even, sometimes they just have leaky buildings and the stuff just leaks out the doors and windows. So there's a lot of chemicals that get out into the air through that as well. Okay, there you are. Transportation, cars, trucks, buses, all that stuff. But look at the construction equipment. I mean, building highways or whatever transportation systems you want. Construction, equipment for building buildings, homes, all that stuff. Those are diesel engines. Those are important as well. Here's a couple you probably don't think about too often. First one, the gas station. Tried to relate what I want to say is small businesses. Lots of little small businesses do things. If I'd had a good picture of an auto body shop, it would have been right up your alley. But a gas station is just the same. We're getting chemicals off of that. That burn barrel, we don't see them in Portland, but I can guarantee you that you get out into the rural areas of this state and you see these all over the place. People are burning yard debris, sometimes garbage, sometimes things that they shouldn't be burning at all, like plastics. And then finally, in this state, this is actually a pretty big one. I think this is a rangeland fire. But basically, this is a natural source of air pollution. We do have rangeland fires in this state, but we have big forest fires. And we have to factor that in as well. And in fact, we work with the Forest Service to some extent on trying to keep the forests healthy so they don't have big fires. Okay, so sources. Sources of what? Now we're going to talk about air pollution. Some of this is semantics. The title of my talk was about air toxics. And you got to be saying to yourself, wait a second. Things like ozone, carbon monoxide, those are toxic. How come those aren't air toxic? That's not what I'm going to be talking about. Those are actually called criteria pollutants. And that's because there's a certain process that EPA follows to decide about a pollutant and what concentration level is healthy, and they establish a national standard. So there's national ambient air quality standards for criteria pollutants. It's a very short list. Particulate matter, 2.5 microns now. Carbon monoxide, ozone, sulfur dioxide, nitrogen oxides, and lead. That's it, criteria pollutants. Those pollutants, because they have national standards, are monitored all over the place. Every air pollution agency around the country monitors those and keeps track of them and tries to determine how they stand versus that national standard. Most of the health effects associated with those pollutants are acute health effects. High particulate levels sends people to hospitals with asthma attacks and things like that, or people that are already sick, have compromised lung function, they'll end up in the emergency room, that kind of thing. And another interesting aspect of the criteria pollutants is that there are also welfare effects, and there are standards that are associated with welfare effects. We talk about crop damage, deterioration of buildings and things. It's not something that gets out there very much, but they're there, called secondary standards. Air toxics, on the other hand, of the thousands of chemicals that are in our work, in the world, in the commercial environment, there's a list of about 180 that EPA, actually Congress designated, were hazardous air pollutants. And they get dealt with in a whole different way. First off, there's no national standards for their concentration in air. So that creates a little bit of a problem in terms of regulation. What's our goal? The approach that's taken with the hazardous air pollutants is the presumption that they're hazardous, and therefore we should try and reduce them to whatever extent we can. It's a little different approach. Because there are no national standards, because all the air agencies around the country don't have to show how they match up against the nationals, there aren't a lot of measurements going on. In fact, right now, there is a national air toxics trends network that has 23 sites across the country. I mean, can you imagine how those are spread out? I mean, you think they're very representative about what's going on in the world? And we probably have 23 particulate sites in Oregon. So, little different way of dealing with it. We're very concerned about chronic low-level exposures, long-term exposures to small concentrations. And that creates some interesting chemistry problems because you've got to make measurements at very low levels. And it's kind of pushing the science of making measurements on chemicals. And it's mostly about carcinogens, other serious health effects as well, fetal development, neurological development, birth defects, a lot of stuff that people are very concerned about and are trying to deal with. In the transportation world, EPA proposed a mobile source air toxics rule almost a year ago, March 29th, 2006. And it was a proposed rule, and they identified 90 pollutants that came from mobile sources, cars and trucks, essentially. You can go to the EPA Integrated Risk Information System, find out the toxicology of many of those, but not all, and they don't all have good information on their risk. It includes such things, what do I have listed here? Benzene, metals, arsenic, chromium, mercury, and combustion products like formaldehyde, acetaldehyde, particulate matter, polycyclic aromatic hydrocarbons. Just an array of different chemicals. In some of the studies that EPA has done, they've identified 7, essentially, that they think are important drivers that relate air pollution to public health around the country. And those 7 are benzene, 1,3-butadiene, acrolein or acrolein, formaldehyde, naphthalene, polycyclic organic matter, and diesel particulate matter. So really out of the whole 90 of them, those are the ones that people are going to be focused on. And the reality in this business is that you can't do everything. You got to prioritize stuff. And so, that's why EPA talked about those 7 in their proposed rule. That's why our legislative agenda is dealing with just 4 things. Okay. How am I doing time-wise? I have no feel for this. I think we're okay. Okay, I wanted to talk about ambient monitoring a little bit, one of the major tools that we use. What you have here is a map of Oregon, and not very readable. But what I wanted to tell you was that we actually have a number of ambient air monitoring networks in the state that are designed for different purposes. We have a criteria pollutant network, which mostly focuses on some of the cities, Portland, Eugene, Medford, Pendleton, places like that, Bend. We have the air toxics network. Maybe I'll hold off on that one. We have a smoke management network, which is about when they burn fields down the valley, grass seed farmers, we have a management network that says, first off, they've reduced the number of acres that they burn by a lot, but they still get to burn about 30 or 40,000 acres a year. And we want to try and keep the smoke away from population centers. So they use a lot of meteorology to figure out how to steer the smoke. They're very good at it. Some years they screw up a lot because the meteorology is not so easy, but they're very good at it. They can move the stuff right out of the valley and drop it right on Sweet Home. And that's where we get the complaints from, And also there's forestry burning. There's what's called prescribed burning, where after you clear 100 acres of trees, take the timber out, you still got all the limbs and brush and stuff like that. They want to clear that off so they can replant, and the easiest and cheapest way to do that is to burn it. And so we work with them to make sure that when they burn it, at least we can direct the smoke again out of population centers, smoke management. We also have a visibility network, which mostly is in the wilderness or near wilderness areas. I believe we have 7 Class 1 wilderness areas in this state, and also out of the gorge. The Columbia Gorge is the only national scenic area in the country, and we want to try and keep visibility good there. Okay, air toxics. You know, we've got a lot of different parts of this state. How many air toxics monitoring sites would you like to have in this state? Oh, give me a number. 20.
40,000.
Ooh, you want one in every house, huh? I get calls from people like you. 3. We have 3. We have one in Portland. There's one in Eugene, which is running about half-time. And we have one in LeGrand. And LeGrand is our contribution to the National Air Toxics Network. And it's intended to be representative of a rural community as opposed to a big metropolitan area. And there's about 3 of those rural kind of sites around the country. It's not, it's not natural air toxics or background. It's, what you would find in a rural community. I personally don't find that's enough. Okay, let me talk about the 2 things on the side. Down at the bottom, a picture of some particulate samplers. These have been around forever in one form or another. They're gotten a lot more sophisticated with very good flow control. They run for 24 hours. Essentially, a pump draws air through a filter. There's the parts on the top are actually size separators. Let's see if I can figure out how to do this up here, so that you get just the 2.5 micron stuff that gets to the filter and all the rest gets someplace else. Those filters are picked up by our lab staff. They take them back to the lab. They find out what the concentration of particulates in air were for that day. And then they can also do some chemical analysis. They'll do metals analysis, and they'll analyze for other things like nitrates and sulfates and a few other things. Pretty, kind of, I don't really want to say old school because they're a lot better than they used to be, but kind of older. The graph at the top basically is a trace where every one of those bumps represents a specific pollutant, and every line is an hour of the day. And this comes from an instrument that was designed and developed by Dr. O'Brien here at Portland State in the chemistry department. And he's got a patent on the process. He's figured out a way, I don't know if any of you know, well, a couple of you know, what a gas chromatograph is. Basically an instrument that allows you to separate organic compounds, and you can see what they are and they come out. Well, he's figured out a way to turbocharge the thing. He takes a big sample of air, squishes it down, shoots it into the machine, and it's boosted the sensitivity of the measurement process by 1,000-fold. So you can do an hourly concentration of something like benzene down to the sub-part per billion level, tenths of a part per billion, hundreds of a parts per trillion. It's very good. Those are the levels we need to be at to know what's going on. And when we can do it hourly like this, and he just sets it out in the field, runs it remotely from his lab here, or what used to be his lab here, I guess. So that's high tech, and that's good, and we're moving that way, and it's going to be handy. When we can do that, we can actually link that up with meteorology. Where's the wind coming from? How fast? Where did that benzene come from? Where did that methylene chloride come from? And that's really useful in terms of control. Okay, I don't usually put slides like this up. Too many words. But the thing I want to impress you with is that when we do an emissions inventory, it is very detailed. We try and figure out every single source of air pollution in this state. And because of that, and I wanted to mention, it's numbered down to 27. I don't know if you can see that. Actually, there was a 28th as well. This is just vehicle classifications. And what you have here are gasoline vehicles mostly. There's another 14 that are diesel vehicles in similar kind of size classes. So we do details like this for all kinds of sources, like home heating. Do you heat with wood? Do you heat with natural gas? Do you heat with heating oil? You know, all those things. And what EPA does is they ask the states to provide a statewide inventory every 3 years. Probably takes us about 4 people working for a whole year to do a complete inventory of the state. It's a lot of work. It includes what we call major sources. Those are the big industrial facilities. Area sources like the gas stations, auto body shops, dry cleaners, things like that. Also, it includes wood heating in homes and other kinds of heating in homes. It includes wildfires. I'm sorry, it doesn't include wildfires. It includes prescribed burning, field burning, all, you know, just a whole array of stuff in area. The mobile sources, and it includes not just on-road mobile sources, but we have off-road sources like locomotives, barges, you know, construction equipment's big. I'll talk about that in a little bit too. The way you do an inventory, there's basically 2 pieces. You've got an activity, you figure out how often that activity happens. So for example, I don't know, thousands of acres of grass seed field burned. And then you have an emission factor. How much pollutant comes out for every acre that you burn? And people have done studies over the years to actually make those kinds of measurements. You multiply the 2 together, and voila, you have how many emissions per year for field burn. And you do that for all kinds of things. For motor vehicles, it gets a lot trickier. You want to talk about day of the week, you want to talk about season, you want to talk about what kind of fuel you got, whether you got a vehicle inspection program like we do in the Portland area. There's a lot of variables, and there are actually models that just sort of do all that for you and give you the numbers, and I won't get into that. Let's see. One of the things I want to say, though, is that every state, local air agency, tribe that has to report does this every 3 years, but they don't always do it the same with the same level of detail. And so that creates some problems for us in terms of comparing what we do in Oregon to other places. And so now I'm going to take you back to that headline, Oregon's air 3rd worst in the country. I happen to believe we just did a hell of a lot better job than anybody else. That's, I mean, I don't think it's real in that sense, but let's see, what else I want to say about this. The mobile source model, version 6.2, actually gives us 6 toxic air pollutants, almost the same ones I mentioned before. Benzene, 1,3-butadiene, acetaldehyde, formaldehyde, acrolein, and methyl tertiary butyl ether. Okay, just to give you an idea about some of the models that are used, I've already mentioned most of the models have to do with taking pollutant from a source, figuring out what the concentration is someplace else. Dispersion models rely a lot on not only knowing what's coming out of the source, but the meteorology and the topography. Portland's heck to model because we have the West Hills, we have river valleys, you know, we have little old volcanoes and stuff that, you know, the air must move around. So it's tricky, but it's doable. There's also, I've given you a website, an EPA website. The SCRAM website is the support center. There's other models there as well. Things like looking at how do you get from what the concentration in the air is to what people are really being exposed to, because nobody just sits in one spot for a while. Students move around in different ways, inside, outside. Little kids do different stuff. Guys like me sit in an office all day. You know. So it's pretty, there's a lot of models. I think I'll just leave it at that. Okay, let's talk about some of the pollutants a little bit. I guess I better pick up my pace. Sources of fine particulate. Just to give you an idea, based on our statewide emissions inventory, this is where fine particulate comes from. As you note, it does not include the wildfires. It does not include road dust. And in some parts of the state, road dust can be significant. It's also just primary emissions. And some of the stuff that gets emitted out of tailpipes in the atmosphere undergoes reactions, coalescing or whatever, and you end up with particles from the gases. Doesn't include that. Now let's talk about toxics. Okay, here's diesel exhaust. Again, from our statewide inventory in 2002, you know, you can see the variety of transportation sources. I'd like you to note how big that agricultural equipment, industrial, commercial equipment, construction equipment, those pieces of the pie are pretty big. And you see long-haul trucks are pretty big. I'm surprised about the delivery truck thing, but somebody pointed out to me, you know, just look around. Look at all those delivery trucks out there, you know, bringing food to restaurants and grocery stores, and it's huge. Passenger vehicles doesn't turn out to be so huge. And trains are big. I mean, you're all familiar with the fact that, you know, we're at a real transportation hub right here. We got trains going in and out. We got sea-going vessels. You know, we got stuff going up and down the river. Okay, I'll just move on. So we're talking about diesel exhaust now. This is from EPA study in '99. Again, kind of the color, relative colors give you an idea where the worst problems are. These are estimates of ambient air concentrations based on those emission inventories. Pretty much any county here that has any color has a level of diesel particulate that we're concerned about. So diesel isn't so bad in a big chunk of the state. So what are we doing about this? EPA is not exactly asleep at the switch. They've been doing a few things. What you have here is a graph that shows particulate matter limits on new engines and nitrogen oxide limits on new engines. And if you look back in 1988, you know, 0.6, that's grams per brake horsepower hour. And was it about 10.5 on the NOx? I mean, those were the limits. Look where we are now, 2007. I mean, we've come quite a long ways in almost 20 years. The trouble is, those 1988 trucks are still on the road. And they're going to be on the road for another 20 years. So it's not just all about new engines, you know, getting better. Some time ago, DEQ adopted this mantra. I mean, basically, everything we think about with respect to diesel comes into one of these three categories. We want to burn less fuel. We want efficiency. That'd be good. Ways to not travel as much. That'd be good. We want cleaner fuel. And getting sulfur out of the fuel was a big step. And EPA did that in 2006, October 2006. Essentially all of the diesel fuel available around the country has much lower sulfur content. And that does a couple things. It's called ultra-low sulfur diesel. For one, it reduces some of the pollutants, some of the particulate, but also it allows you to put controls on the diesel trucks and remove more particulate. It's like in the old days when we were trying to get lead out of gasoline, or I'm sorry, we needed to get lead out of the gasoline not just because it was a health hazard, but because it poisoned the catalysts on cars, and so you couldn't have the catalytic converters work well. It's the same kind of deal. And then, of course, you want the engines to burn cleaner, and like I said, EPA is kind of doing that. Right now, I was surprised to find this out. So I was researching this talk. The guy who does most of the diesel work said, right now the U.S. has the cleanest new engine standards and the cleanest on-road fuel of anywhere in the world. So that's pretty cool. But I'll get back to what I said before. Old engines are still out there. So we got to do something about old engines. And actually our legislative agenda deals with it in a few ways. We've got a House bill that hopefully will sail through the legislature and we'll get everything we want. It includes a tax credit for new trucks, new engines. It basically extends a credit that we had before. It extends it out to 2011. There's a clean diesel fund, which will give grants and loans to retrofit or rebuild public and private diesel fleets to get rid of old engines. And we're asking for $3 million for the biennium. There's a clean diesel tax credit. Again, similar. It's a retrofit, rebuild. You can get a tax credit. If you do that to your engine, that's money. There's a clean school bus fund, which would specifically provide ways for Oregon school districts to get new engines or to rebuild old ones. And then it's not part of the initiative, but another thing that we have going on that's kind of a big deal is something called the West Coast Collaborative, which is working with California and Washington to try and do things along the I-5 corridor. And what they're trying to do, it's an anti-idling measure. What they're trying to do is electrify truck stops so that when trucks go and park there overnight, they can have heat, they can have computers, they can have, these truck drivers in their cabs have pretty good deals. Electrify all that so they don't have to run their engine all night and keep all the electrical stuff going. So we're trying to work on that, all along the West Coast. There's other things that they're doing as well. And I guess I should mention the clean diesel tax credit does not just apply to trucks. It's also for marine engines and rail engines. Okay, let's talk about benzene. Benzene's big. But, whoa, what is this? There's other pretty big sources of benzene. I mean, on-road gasoline vehicles, almost half. That's still pretty big. You add in the non-road gasoline, like the guy mowing his lawn, and if you add in the gasoline distribution, it's, altogether, it's the biggest piece of the pie. But, we have to deal with wood stoves as well. There's open burning. I showed you the burn barrel a while ago in some parts of the state. That's pretty significant. And again, we've left out wildfires, which also, surprisingly, benzene comes out of wood. Okay, here's another graph showing what EPA studies showed us about ambient concentrations. Oregon's established a benchmark concentration, a concentration of benzene in air that we say, if we can get below that, we're okay for now. And essentially, every place in the state is over that benchmark. But you can see relatively where the bigger areas are. That one down in the south, Medford, Klamath, somewhere in there. Here's a little something about how ambient benzene levels have gone from 94 to 2000. These are concentrations measured in air. I mean, they've dropped down some. What you've got is the 10 to 90% kind of confidence interval thing. And I actually got to change my slide, or what I was going to say about the slide, because of something that happened today. But actually, I'll end the suspense. Today, EPA announced that they have a new mobile source air toxic standard, which has to do with benzene content in gasoline and a few other things. And because of the uproar that we created, and we had the whole Oregon congressional delegation writing letters to the EPA administrator, we had the state legislature writing letters to the EPA administrator, we had a lot of citizens writing letters to the EPA administrator. Because of all that, they've actually managed to work out a new rule that's going to drop our benzene in gasoline concentration more than they originally proposed. We're still going to be probably higher than other parts of the country, but they've dropped it. It's going to be really helpful. And the one thing I want to say, the one thing I think about when I think about benzene and gasoline is that at one time we had lead in gasoline. Eventually we got it out of there, and boy, that really took care of the lead. And if we could do the same thing with benzene, if we could really keep driving that number down, we could lower the ambient concentration, and it would really be helpful. And there was the other thing I was going to mention. That conflict between benzene and third worst, one of the reasons our benzene wasn't as low as other places was because our air was good. Well, because we met all the national ambient air quality standards, we didn't have the authority to do stuff about lowering benzene concentration. The way the national system is set up, if you had problems with ozone, you could require that gasoline in your area have lower benzene concentrations. But since we met the standards, we couldn't do that. And so it turns out that our refineries weren't refining gasoline to the point where they had that lower benzene concentration. Meanwhile, back east, and in big metropolitan areas on the East Coast, they already had lower benzene. So anyhow, clean air kind of hurt us in that respect, but citizen involvement, sending those letters, that really helped. I want to show you a little something else we did here at DEQ. This was a pretty good study. We've been working on boosting our scientific technical capacity and being able to predict concentrations of a lot of toxics in our cities. And what we did was what we called the Portland Air Toxics Assessment. We did a very refined emission inventory for just the Portland area. And I know I told you that the emission inventory was already pretty detailed. Well, we made it even more detailed. And we worked with Metro. They have like the best modelers on traffic stuff anywhere in the country. And we got stuff really good. And we worked on the area source stuff. We counted up every dry cleaner there was and put them on a map and things like that. Anyhow, we did this modeling exercise. And what you see here, those lines are lines of constant concentration of benzene. So if you're familiar with topographic maps, altitude, you kind of see yourself. What you see is as you go from here, this is I think 3.035, on this way, you're going up a hill. So the concentration here, which is what, 405, I think I had Burnside picked out here somewhere, So the concentration of benzene in this area is higher, as you would expect, from concentrations over here by Forest Park. EPA's modeling gave it to us by a census tract at best. Mostly it's by county. So this gets it a lot more into neighborhood scale. Not quite 40,000 monitors out there, but it's probably true. And the reality is, I haven't said a whole lot about modeling, but you can't put 40,000 monitors out there, but you can model. And in the Portland area for this modeling study, we had 935 receptors. That's pretty good, and we had them all over the Tri-County area. And the one thing I want to say is we've also done some monitoring around Portland, and the monitoring pretty much confirms the modeling. It's within a factor of 2 for the most part, and that's really good. That's really good. So, for example, if the model says it's 3 micrograms, we might be measuring 1.5. That still tells you what's going on. If the benchmark concentration is 0.1, then you still got a problem. Okay. What are we doing in Oregon, aside from what the feds are doing? The big thing was low emission vehicle standards that we adopted for this state. We followed California's lead. Basically, we opted in. We said, whatever California says, we're going to do the same thing. When we did that, the state of Washington jumped on too. They were chicken. Their legislature said, we're not going to do this unless Oregon does it. So we had all the pressure on us. We did it, and Washington's now behind us. This goes into effect in the 2009 model year, so we'll start seeing those cars not next fall, but probably the one after. It applies to light-duty and medium-duty vehicles, and it actually phases in. Those reductions aren't all going to happen right away. They phase in over a few years to 2016. It was mostly done about greenhouse gases, but we got reduced pollutants as well, toxic pollutants as well. Other things we got going on, the benzene content thing I just told you about. I don't know that it came out so well in the newspaper, but there are 2 reasons why it came out. One, I already mentioned, we already had clean air. The other is we get all of our crude oil comes from Alaska, goes to refineries in Washington. Not all, but almost all. And that crude oil has a higher benzene content to start with than crude you get out of Venezuela or out of the North Sea or someplace like that. So we're already starting harder. But anyhow, that's all taken care of now. In addition, the department is looking at the gasoline distribution system and trying to, we're hoping we can do something about improving that so the vapors are collected. Not only when the truck comes and fills the underground tank, you can collect those vapors back into the truck, but when you fill up your car, and in the Portland area they actually have this vapor control, but the rest of the state doesn't. When you fill up your car and they push gasoline into your car's tank, the vapors go back into the pump and are collected. So it's vapor recovery on a couple levels, and we're trying to do that statewide. Okay, let me let me back up and give you maybe a little bit big picture even at this point. We've seen all this stuff. I've talked a little bit about what the feds do, what the state does. Some years ago, we decided that, here in Oregon, we decided that the feds weren't going fast enough, weren't doing the things we were concerned about. Most of the federal work on toxics was focused on big industries. And they started out with coke ovens, steel making. I mean, they had no usefulness for us at all. Pulp and paper industry, one of our really big industries, was way down their list. So we started thinking about what we could be doing in Oregon that met our needs. And we worked with a couple citizen advisory groups, big stakeholder groups, and came up with a program. So what we have here is, at the top, the federal technology-based standards. These are industrial standards. There are about 170 different industries. They said, okay, you got to put this kind of control on your stack, or you got to use these management practices to reduce your air toxics. And we basically do that program for the feds. We write permits for these sources, we inspect them, and we deal with the big sources. Those are the major sources. Over on the right side, the mobile source program, I've talked about that a bit. I mean, the feds basically have control over engine standards and fuel standards. There's not a whole lot we can do about that. Although the Oregon low emission vehicle is one thing we could do. So we've been working on a lot of voluntary programs to do things about diesels, especially. And we have the Oregon Clean Diesel Initiative. I mean, that's kind of part of the West Coast Collaborative, working with other states. And we have other things going on there. But the big thing that we worked on was called the Oregon Air Toxics Program. The thing is this. In Oregon, most of our problems are in urban areas. And they're not just caused by some big source. They're caused by lots of little sources. And mobile sources, stationary sources, lots of things. And we needed a way to work with the community to figure out what's the best solution to that problem. I mean, what do we want to do? Do we want to keep all the cars out of downtown Portland? Or do we want to make sure all the dry cleaners don't use perchloroethylene? Or what exactly? And what combination of things would make sense? Benzene is a good example. As I showed you, benzene comes from a lot of different sources. I mean, if you want to get benzene down in the Portland area, how much of it has to do with transportation, and how much control should you put on wood stoves or home heating? So that's the approach we wanted to take in Oregon. And so we set up this whole body of rules, air toxics rules. It's got 3 components. The major component is what we call the geographic program, an idea of look at a geographic area, see what the problem pollutants are, see what the sources are, work with people to figure out how to reduce those to levels we can handle. That's the big piece, and that's hard. The second approach is the source category approach. Okay, identify a pollutant, diesel exhaust. And let's do something about all the sources of diesel exhaust, category approach. And the third one we call the safety net program. People were concerned that with those 2 approaches there might still be some things you'd miss. There could be a moderate-sized industrial or manufacturing, making maybe cabinets or something in some small town in Lebanon. Neither the geographic program, since we got to prioritize our urban areas, we'll be in Lebanon in 3010 talking to them. The source category maybe wouldn't handle particularly what's going on, although my cabinet making was a bad example. So anyhow, we wanted a safety net program, some way to get anything that might fall in the cracks, and so we've got that as well. And this is unique to Oregon. It follows on some work that EPA did originally, and they had a report out in 2001. But no other state in the country is doing it. A lot of states are looking at it. I mean, they consider it a model because, I mean, we think it's going to work. We haven't really tried it with toxics. It's the model we've used when we talked about ozone. How do you control all the sources of volatile organic compounds that are in a city to reduce the amount of ozone that's formed? So we have yet to really kind of get rolling on this. We'll see how it goes. Okay, I'm going to finish up here. Just wanted to give you a a little bit of legislative overview again, what we're working on in the Clean Air Initiative. We're worried about benzene, diesel, fine particulate, smoke, combustion products. And we've got source category approaches kind of for all those things. We have a heat smart piece of our legislation that's going to attempt to get rid of old uncertified wood stoves and replace them with new cleaner burning stoves, or maybe even get people to use natural gas or something else besides wood. Let's see, it's also going to give us some more money for monitoring, so we can get out around the state a little bit more and see what the story is on toxic chemicals. Our bread and butter core program is industry compliance, making sure they have permits, they know what they're supposed to be doing, making sure they're doing it. And the Columbia River Gorge visibility is another big thing, and that's part of our initiative. There's a big study, scientific study, that's kind of winding down right now, and they're going to have some recommendations about what we need to do. Greenhouse gases, it's interesting, DEQ hasn't had much involvement with greenhouse gases up until now. All that energy, I mean, it was all energy-related stuff, so it was done by the Department of Energy. But now we're working more with the Department of Energy to help them figure out what we can do. And I think that was about it. You know, DEQ is doing stuff. You probably all know, you've heard all the sustainability things. I mean, there's things every one of us can do, choices we make every day that can kind of help the situation. I just, you know, my being here, you know, I kind of like to leave the message that transportation, urban planning, I mean, you guys can do a lot. I mean, as you saw, transportation's involved with a lot of this stuff. And I hope you keep in mind the air quality aspects of it, the public health aspects of it. Certainly there's economic aspects and all that stuff. You probably hear all that. And you guys know a whole lot more than I do about what you think about when you do transportation planning. But I just wanted you to keep in mind air quality, public health as you do it. So, thank you. I'm about done. Here's some phone numbers, people to call if you want to follow up on any of these things. Our DEQ website, which you can reach through Oregon.gov. And any questions?
And remember to use the microphone.
Okay, I'm going to start on the left.
The diesel engine standards apply to off-road vehicles as well?
There are different standards for off-road vehicles. And EPA has done some things lately. I don't remember the specifics, but there's new off-road engine standards that are coming out with you know, a phase-in time and stuff. Yeah.
There was an article in the New York Times last week about a study that came out of the California Air Resources Board that reiterated an EPA study that people living within a third of a mile of a freeway, particularly children, are at risk of permanent respiratory damage. Can you talk about, I didn't see what the science was behind that, and if DEQ is doing anything to try to reduce the risk?
I didn't read, I mean, I was aware of the study coming out. I didn't read it all. I know that a lot of it had to do with fine particulate. I think that's the one. There were two that came out real recently that showed similar kinds of things. There was one about women's health, and then there's one about kids' health. And both of them show pretty much the same thing. If you live close to heavily traveled roads, the health impacts are greater. And in fact, the Portland Air Toxics assessment that we did, I mean, the isopleth lines, you know, line up with roads. The big hitters are along the Interstate 5 corridor, I-84, you know, things like that. So there's not much we can do other than tell people that. I mean, really, we're dealing with the engines, we're dealing with the fuel, we're telling people not to drive as much. I mean, if you have some other suggestions about what we can do, see, I look to this group to do something about that. I get phone calls from people that say, gee, I saw that study in the paper, and my daycare center, my kid's going to a daycare center that's, you know, 30 feet off of 217. What do you think? And I say, well, you know, there are studies that show that the closer you are to highways, you know, the more likely there are to be health effects. Do you have another answer?
Sure.
Okay.
If you participate in transportation planning studies, there's still proposals to add freeway off-ramps, to add lanes to freeways in this area, to expand capacity for people to drive more and drive further. If this is a serious public health threat, and it appears to have some level of seriousness, and particularly for kids and the elderly, then maybe weighing in and encouraging, instead of adding additional lanes for more cars and more trucks, other schemes, pricing, which reduces congestion and
Congestion
reduces,
pricing.
Discretionary trips, adding additional transit capacity instead of adding passenger vehicle capacity. And I know that the current politics do not, you know, DEQ is not a heavy hitter in any of this, but what we're dealing with is changing perceptions, and when you have new studies, particularly around kids' health, you have opportunities that you didn't have in the past.
Totally agree with you. I didn't mention it, and it was in my notes, but I skipped over it. I mean, we have people who are working, you know, with the transportation agencies, TPAC, JPAC, here in the metro area, you know, to continue to raise these health issues and to bring forward this research that we're aware of. You know, we do what we can. It's like I said, it's, you know, it's one factor that people consider. And one of the people, I didn't mention Mary Ann here. I mean, Dave's kind of our point person for transportation, but Mary Ann Fitzgerald is involved in the Columbia River Crossing project. And you know, I can get you her phone number too. She goes to all the meetings and she, you know, puts in 2 cents. And I've even gone to some meetings on the I-5 widening at Delta Park. And, you know, we push for them to do something about air toxics. Federal Highways doesn't want to talk about air toxics. They just want to talk about the criteria pollutants. And the community knew enough to say, we want to know about air toxics, and we backed them up. Back there?
It's a related question, so perfect. I work in Central City stuff and planning, and we would love to find out if through those maps of the central census tract you can isolate how much of that emissions, benzene for example, is due to the highway versus what's on the surface of the central city. Because if you look at it from the map of the Oregonian, it shows that the central city has very bad air quality, but in reality, if you work and live in the downtown, you're actually producing less emissions. And a lot of the emissions come from being in the freeway loop, which carries a lot of regional traffic. So we're actually here being punished by being close to the freeway. So it would be great to we could separate how much of a census tract emissions come from the freeway system versus from local trips. Is there any such way of doing that?
Okay. I don't know the answer to that. I think it may be there. I think it may be there. Why don't you give me a call? Oh, I did put my number up there. And I'll see if I can put you in touch with the right person. There's one of several people. I think we might have that. Because Metro did a lot of work, as I said, and, well, I'll just leave it at that. Sure.
So, a couple of comments and a question. Question first. The modeling that you did for
Sorry, slow with this. So question.
Couple questions, or a couple
Yes,
comments and a question.
That's
there
right.
we go.
So the modeling work that you did with Metro to get the Portland air toxics assessment.
Yes.
Did you use the same methodology that when you started off with the NADA data set, the natural air toxics assessment? Is it essentially the same emissions inventory that you used for the NADA data set? And if so, great. If not, what was different about it?
That's a long answer. We started with the NADA data set, and we started with the Portland area study actually was 5 counties. We had, aside from Multnomah, Clackamas, and Washington, parts of Columbia and Yamhill. And we started with those county inventories, and then we kind of drilled down and like I said, did a little better job of placing some of the stationary sources, did a whole lot more work with Metro, and they gave us much more refined information. I don't remember exactly how it goes for the national emission inventory, but I think it's done on a county-wide basis. It's got to do, it's some simple activity level like vehicle miles traveled in that county, and I don't even know that they break it down by vehicle class very much. Oh yeah, they must. Sure they do. Sure they do. That's what Mobile 6 does. But so we did more about, the question the other gentleman was asking about what kind of trips they were, what time, those kinds of things.
One more
One
follow-up. The total cancer risk, is that an addition? Is that essentially a sum of all the
Individual cancer risks.
individual cancer risks? Okay, so it's a sum, no interaction effects or anything?
Well, not only no interaction effects, but we aren't even worried about whether it's the same organ system that's getting cancer. So, I mean, it's coarse. I would agree. Sir.
Yeah, so one of the strategies for dealing with air pollution that you laid down was meteorological and letting it blow into, say, Idaho. But Idaho's generating their own pollution and so on. And so to a certain extent, away is gone away. And so you have to rely on things like suspended particulates settling and these more exotic organics breaking down in the atmosphere and so on, so that instead of this stuff sort of accumulating, it diffuses and dissipates and gradually enters some kind of cycle. Another thing that you talked about was designing these things out in the first place, like taking the benzene out of the gasoline before it's even burned, and that's clearly going to be a very effective strategy. But I was wondering if there was any thought given. What's the sort of the state of the art for those pollutants that get into the air to sort of like catalyzing them to speed up that breakdown or sinking them in some way? I was just wondering if there was any work being done in that area.
That's really interesting. I haven't ever heard anyone talk about doing stuff after it gets out there, like cloud seeding or something like that, right? No, I haven't run into that. I guess I can back up a little bit. It's not just all about managing the smoke. There was quite a bit of work done to look at different lighting techniques that produce less pollutant. We've done things with the Forest Service about moving when they burn so it produces less smoke, things like that. But, that's counterbalanced against their concerns about starting massive forest fires and things like that. So, very interesting. Although I remember a long time ago we used to talk about building giant fans around the Medford Basin because it's like a bowl in there, and what we wanted to do was suck all that bad air to the coast or something. But seriously, dilution is not the solution to pollution. Okay, who else? Do we have one here?
So did you look up at using
Biofuels? I'm sure you could find somebody at Air Quality that could talk to you about biofuels. I know biofuels are good in terms of reducing greenhouse gases, and they have sort of mixed effects on some of the toxics and some of the other pollutants. But if you wanted more, who do I have up there? I don't actually have anybody up there for diesel stuff, but we could get you somebody. Yeah.
Question about aircraft emissions. Is that something that's measured, regulated, or any sorts of emissions?
We included aircraft, and I'm glad you mentioned that. I should have mentioned that we included the Portland Airport, Troutdale Airport, Hillsborough Airport, I think even Fort Vancouver when we did our Portland study. There is some information on emission factors for different kinds of aircraft. There's pretty good information about activity level. I mean, we know how many flights go in and out of PDX, that kind of thing, and what kind of planes they are. But there's really there's been a lot of work recently to try and get better information about what's coming out, in the exhaust.
And what about standards?
I don't know anything about. The question was, what about standards for aircraft? I don't know anything about the standards for aircraft. I have a hunch it's handled by the Federal Aviation Administration, and we probably can't touch it. Sir?
Just two questions. Why don't we stop allowing people to burn their garbage? And two, can you talk about the difference between the passenger vehicle, diesel-powered passenger vehicle fleet proportion between the U.S. and Europe, where basically there are a lot more diesel passenger cars in Europe and very few here?
To answer your second question first, that's what I know. But if you wanted more of a breakdown, Dave might be able to help you. I don't have any particularly good answer on that. And why do we let people burn garbage?
Whenever I come back from Mount Hood, there's always some big pile of garbage burning out on 26.
In theory, at least, people in rural areas are allowed to burn selected materials that we would not call garbage. Yard debris, clippings, prunings. You know, you get into kind of strange things. I mean, we have a big nursery industry surrounding the city. You know, how do you keep a homeowner who's living next to a nursery, and the nursery's allowed to burn their prunings, and the homeowner isn't? I mean, very difficult things to work on. What's really cool, though, I never thought this was going to happen, but we've been getting reports now from some small cities around the state, city councils, passing local ordinances to prohibit backyard burning. And, I mean, I really thought, you know, that was going to be like, you know, owning guns. You know, burn barrels, you can't take that away from me. And it may be changing. I'm really impressed. But that's what it's going to take. It's going to take enough local citizen involvement to do it. If there was enough of a groundswell, then, you know, we probably would try and make it statewide. But we're not anywhere near that yet. It's a tough one. We have a lot of agricultural industry in this state, forestry, where, you know, burning happens. And it's hard to talk to people and say, you shouldn't do that little bit of stuff when, you know, right over there. Sir?
No, it's actually not plugged in there. Behind you, not sure which one it is.
Reach, yeah, go behind.
Here you go. I'm just wondering if there's a general rule of thumb that DEQ adheres to versus is a threshold beyond which, if you're making a short trip, whether you leave your car idling or whether you turn it off and you start it.
I don't know what the agency says on that. I would be surprised if it didn't show up in one of our fact sheets someplace. I don't know the number. Somebody here must know that.
You know, these days with newer cars, it's really, really short. And
It's like 10 seconds, isn't it?
yeah, it's definitely a minute or less these days. So
I think that's true. That was kind of my recollection, was under 20 seconds or some such thing. Sir?
Do you know, is the DEQ involved in the creation of markets such as those for carbon sinks to be able to offset emissions and at the same time maybe conserving open space?
I believe the carbon market thing is at the legislature right now. They're talking about it. As I recall, Mary Ann is actually going to some stakeholder meetings, I guess, in Salem. There's been a group working on carbon trading, and so she's involved in those discussions. I don't know, what's going to come of it, but people, yeah. The short answer was yes. Anybody else? Really? Oh, okay, good.
Has there been any discussion about having a vehicle fleet retirement program? In other words, to sort of encourage people to get rid of their older, inefficient vehicles?
Yeah, more than discussion, actually. It's a voluntary kind of thing. We've never really had the budget to incentivize that, to offer people money. But I don't know if you've ever noticed, if you've done taken your car through vehicle inspection lately, there's a little box right there where you pay for your tags and pay for the test, and it says, how would you like to donate? to this fund, that what we have is an agreement with some of the local auto mechanics to fix up cars that low-income people have, that, to bring them up to standard, if you will, when they can't afford to do it. And, it's pretty low key. It doesn't accomplish a lot, but it does a lot for a few people. And it's kind of a nice idea. And we've talked about lots bigger things than that, too. But so much of it comes down to dollars, and that's been problematic. Have we run out? Thank you very much.
And I'll thank you. And I will announce next week we have Bob Hastings from TriMet and Brian McCarter from ZGF Architects talking about the Portland Mall revitalization, designing a great street. So hope to see some of you next week. Thank you, Greg.
You're welcome.